exponents, negative and zero exponents. But before we talk about negative and zero exponents, we're going to do a quick review on powers and exponents and what that means. You should have been introduced to powers and exponents in earlier grades. We're going to start with exponents are also known as powers. You guys heard the expression AKA. Exponents are also known as powers. And we're going to go ahead and write this expression. Aiden, can you see? Okay, you're writing exponents, aka powers. We also call them powers. And then we're going to go ahead and write this. A big 2 with a little 4 up at the top right. Big 2 with a little 4 at the top right. So this whole thing is called a power. So the whole expression, we would read this 2 raised to the 4th power, or 2 to the 4th power. The crazy thing is, 2 to the 4th power is a power, but that little 4 up the top right-hand corner, we call that the exponent, but we could call just that part of the power as well. Tony, honey, write what we're writing. Oh, yeah. Do you have everything I've written right now? Yeah. Okay, well that's what I want you to do. You got to pick up your pencil. I'm sorry you're upset, but might as well not get behind, right? Alright, so the entire thing is called a power. Negative 4 in the top right-hand corner, that's an exponent. And we can also call that a power. That's why we read it 2 raised to the 4th power, or just 2 to the 4th power. The big number, the base. Now I'm using constants here or numbers, but you can also use variables for the base. You can actually use variables for the powers, but we're not going to do that right now. Right now, we will have problems that have variables in the base, but not variables as an exponent or a power up here yet. Does anybody know what 2 to the 4th power means? What does 2 to the 4th power mean, Caleb Berry?
2 times 2 times 2 times 2.
Very good. So an exponent tells how many times the base is the factor. That means that 2 to the 4th power equals 2 as a factor 4 times. So there's 4 2's being multiplied. Exactly right. So 2 to the 4th power says 2 gets multiplied 4 times. 2 times 2 is 4. 4 times 2 is 8, and 8 times 2 is 16. I'd actually like to show you how you do that on the calculator as well. So if you did not get a calculator, you do need one. Anybody else not have a calculator? Hurry, what's your desk number? Sorry? Anybody else need a calculator? We're not going to do a lot of things with the calculator today because mostly we're going to work with variables as the base of these. But I do want to show you, I'll make sure that I show you when I think about it so you'll know how to evaluate a power on your calculator. So we're going to use, on the calculator, I'm going to turn it on, clear it out 3 times. And then we're going to do 2. And then you're going to press the Y to the X button. It's right below the off button. Press 4, and then equals. So on your calculator, you press 2, then you press the Y to the X button, and that button is right below your off button. Then you and you will see that that is 16. So, right there. So 2 times x. 2 times x, 4 equals 16. Okay?
Well, I got my movie.
Oh, I forgot the 4. Thank you, Mr. Paul. Yeah, we got 500. Let's do it again. So 2 y to the x, press the 4 button, and then equals, and the display should say 16. So try to clear your calculator out 3 times. Then 2 y to the x, 4 equals, and on your display it should say 16. Remember, 2 to the 4th power is not 8. It's not 2 times 4, okay? Alright, so it's about as what I planned on doing for the review for a power. Does anybody have questions? Anybody need more review on what a power is?
No.
Sam?
If we like times it to 0.
We're going to talk about that. Not times it by 0. If you times it by 0, I mean 0 to a power.
Yeah. No, like it's 2 the power of 0.
Yeah, we're going to talk about that. Thank you. Good. We will talk about 0 powers here in a second. Alright, so the next thing we're going to talk about, a negative exponent. So a negative exponent means the expression is a fraction. I don't know how much you've worked with scientific notation. We're going to work with that a little bit tomorrow. On today's worksheet, while I'm thinking about it, you're doing problems 2 through 26 even. So go ahead and write that on there. 2 through 26 even. So you're not doing any scientific notation today. But tomorrow, we will add to our notes and we will talk about some scientific notation. But today, for your problems on this worksheet, you're doing 2 through 26 even, which means you won't do any scientific notation today. But you probably sometime in science worked with scientific notation. Scientific notation is the method or the kind of shorthand we use to write really humongous numbers or really tiny numbers, right? And we write those as powers of 10. If the 10 is raised to a negative number, then we know it's less than 1 because it's a fraction, right? So that's the same premise we're talking about today. And like I said, tomorrow we'll talk specifically about scientific notation. All right, so for example, if we have 3 to the negative 2 power, because that exponent, this little bitty exponent, this power that is the exponent is a negative number, I now know that this expression simplifies to something less than 1. All fractions are less than 1, right? All fractions are less than 1. You can have a mixed number that has a fraction in it, and that can be more than 1. But if it's just a fraction, it's got to be less than 1. So we are going to learn how to write this as a fraction. The first thing we're going to do is rewrite it as a fraction. Actually, let me show you and then I'll let you write it. Just pause for a second. We're going to rewrite it as a fraction. So we're going to write it as 3 to the negative 2 power over 1. Don't write anything right now. Just watch me. Just watch and I'll give you time to write. Just wait for a second. Alright, so this was our example. If we make it a fraction, that means you're just going to put it over 1. Sydney, get up off your thing, baby. You're going to fall asleep. All the way up. And then the next thing we're going to do is we're going to flip that fraction and turn the negative to a positive. So this expression actually equals 1, 3 to the second power is 9. Okay? Let's go ahead and write that and we'll switch our notes. So let's go ahead and do this and then I'll uncover that so you can write that. So we're going to do the example first and then kind of explain what we did after. So 3 to the negative second power is actually 1/9. Does that make sense? I mean, maybe not, but you understand the process, right? why is it that way? I can kind of show you an example if you want to know why negatives are fractions.
No.
If you don't want me to explain it to you, I don't have to. As long as you can just follow directions, I'm good with that. But if somebody wants to know why, it's a pretty easy explanation. So, what did we do there? We rewrote it as a fraction, which means we put it over 1. So rewrite as a fraction, that was the first thing we did. Then we moved the expression with the negative exponent to the bottom, and that's the second thing we did. And when we moved it out of the top, we can't leave nothing in the numerator, so when we move it out, we always leave a 1 there. If there's something else, we don't need the 1. And I'll show you another example of what I'm talking about. Jeremiah, do you need to stand up so you can stay awake, honey? Okay. Pick up your pencil, start writing, that might help you stay awake. Sydney, sit up off your sweater, honey. Okay. Let's see.
Wait.
Oh, I'm going back. And then the third thing is to simplify the exponent. And that just means do 3 times 3. So let's add that part. So the thing about exponents is, for our final answer, we can never have a negative in it unless it's in scientific notation. And right now, we're not working with scientific notation. So none of your answers, when you simplify the expressions, that's what we're going to be doing. We're going to be simplifying the expressions that have zeros as exponents sometimes and have negative exponents sometimes. When we simplify an expression that has an exponent in it, that means we have to get rid of the 0 exponents and we have to rearrange the power so there are no negative exponents anymore. Are you caught up with me? Does anybody need more time? Are you caught with me? Aiden, you need more time?
No, I'm good.
Okay. So, you don't have to write that part, we already did that. So any number except 0 raised to the 0 power is 1. So, for example, 3 raised to the 0 power equals 1. X raised to the 0 power equals 1. I'm glad you asked why that is. It's a pretty simple explanation. So I'm going to use variables. We've canceled enough things and cross multiplied and all that stuff enough. So I'm going to show you, well actually no, let's do this. Let's do 3 cubed. If you have an exponent of 3, we pronounce that as cubed. Or you could say 3 to the 3rd power divided by 3 to the 3rd power. So that's the same as 3 times 3 times 3, all divided by 3 times 3 times 3, right? We simplify each of those, it equals 1. We know that anything divided by itself equals 1, right? There's a shortcut we're going to learn, not really, oh bless you, not really today, but there's a shortcut. You can subtract, so when you're dividing exponents, you can subtract them. So this would be 3 to the 3rd power divided by 3 to the 3rd power. We could do equals 3 to the 0 power. Anything, so now we have 3 to the 0 power equals 1. Kind of makes sense? Okay. We're going to learn how to use that shortcut. with the grouping symbol. So let's say we have 3 to the 0 power x. The only thing that that 0 applies to, you with me, Tony? The only thing that 0 applies to is the 3, right? It's 3 raised to the 0 power times x. So that's going to be 3 to the 0 power is what?
1.
1. So that's going to be 1 times x, which is equals x. And if we have, so we're going to call that, so we're going to do another example. Now what if we have 3x, grouping symbols, parentheses, to the 0 power. Now everything is raised to the 0 power, so now that entire thing is 1. Does that make sense, Jacob? So it depends on where in the expression that 0 is. The exponents only ever apply to what it's directly to the right of, right? So this 0 is directly to the right of these parentheses, and inside the parentheses is the entire expression 3 times x. Here, this 0 only applies to the 3s, to the right, up and to the right of only the 3. That makes this the base, this the exponent. Here, 3 times x is the base, and 0 is the exponent. So anything raised to the 0 power is 1, but it does depend on where that exponent falls in the expression and whether or not there are grouping symbols or not. Sydney, I'm going to have to ask you to stand up, baby. Okay, then don't put your head back down because you're falling asleep. All right. I don't remember what's under this box. We do need to know what it means to simplify an expression because your directions say simplify each expression. When they ask us to simplify an expression that has an exponent in it, it means there cannot be any like factors. So I'm trying to see what they're even talking about on that one. Let me grab this sheet. Oh. Yeah, so you can't have like x times x left in it, right? So if it's, for instance, so for example, if we have 3x times 2, right? So that's 2 to the 2nd power. So if we're simplifying this expression that has a power in it, that's going to be 3x times 4, and then it's going to simplify to 12x, right? We can't have these like terms. 3 and 4 are like terms, or like factors. We can multiply those. Since we can simplify 3 and 4, we can't leave the 3 and the 4 in our answer. We have to go ahead and multiply that as part of our final answer. We can't have an exponent of 0 left in it. So we can't have any 0 exponents left in it. And let's just say we can't have 0 exponents. Let's just leave it like that, 0. So I think that's self-explanatory. Just scratch that. And we can't have negative exponents. So if you can multiply something or add, if you can multiply something, you have to multiply it. If you've got a 0 exponent, you've got to simplify it to 1 and then evaluate the expression. If there's a negative exponent, then you've got to rearrange that expression. And the way we do that is you're going to move it away. You're going to move it, if it's in the top, move it to the bottom. If it's the bottom, move it into the top. And we're going to do some examples, so I'll show you what that means. All right, so let's do some examples. These are not your homework assignment. Okay. We are going to simplify this expression. 2.3 raised to the 0 power. So you guys are writing, this is example 1.
Okay.
2.3 raised to the 0 power simplifies to what?
2.1.
Anything raised to the 0 power equals 1, right? So this simplifies to 1. Anything raised to the 0 power equals 1. All right, let's look at number 2. 10 raised to the negative 4th power. So 10 is the base, negative 4 is the exponent. We had an example like this in our notes, right? We said the first thing we're going to do is what? Turn it into a fraction, and we can do that just by putting it over 1. Now what are we going to do with that next?
Flip it and put it into a positive.
Yes. Flip it and write it as a positive. So we're going to do 1 over 10 to the 4th power. And then we're going to simplify that or evaluate that exponent. So now on our calculator, we're going to leave it as 1 over, and we're going to put 10 to the 4th power in on our calculator. So clear it out 3 times. 10, y to the x, 4 equals. So it's 1 10,000. Now, number 3 is, we have to make sure we're reading this correctly. This is 2 times a to the negative 5th power. Something we didn't talk about. Do you guys know what the exponent is on a factor if you do not see one, Sam?
We also have to write the one on the left side.
So you have to write everything I wrote here. Yes. 10 to the negative 4th power is actually 10,000. Taviana, are you keeping up with me? Do you guys know what the exponent on this 2 is?
No.
If you don't see it, it's 1, right? 2 is 2 to the 1st power. X is x to the 1st power. Kind of like when we don't see the coefficient, it's 1, right? It's the same way with an exponent. If you don't see an exponent up and to the right, then we know that that is 1. So 100 is really 100 to the 1st power. Right? X is x to the 1st power. So here, this is 2 times a to the negative 5th power. So when we simplify this expression, 2, that factor 2 is not part of that negative power. All right? So when we solve this expression or simplify this expression, it's 2 to the 1st power times a to the negative 5th power. So now we're going to keep this 2 here, and now we're going to do what we did here. We're going to put this over 1 and flip it. Does that make sense? And so our final answer, we multiply 2 times 1 is 2 over a to the 5th power. And as we get a little better at these, we can take some shortcuts with this. But this would be our final answer for example 3. What is 113.7 raised to the 0 power? Mm-hmm. Just go ahead and put that one in your notes. Let's skip on and let's do example 6 here. So go ahead and write this example, write this problem. What is the exponent on this p if I don't see it? 1. So everything has an exponent. If you don't see it, it's 1, right? So p is a positive exponent. 3 is a negative 3 exponent. So we're going to do something a little bit different. We're not going to flip it. That p can't move to the top because that p has a positive exponent. So we can move negative exponents around to make them positive, right? So the only thing we've worked with is if they're in the top, we can move them to the bottom and make them positive, right? Later on, we're going to work with some, the negatives are in the bottom, and we can move them to the top to make them positive. But for now, we are going to give ourselves a fraction. We're going to move 3 to the third power to the bottom. It's times p. Since we moved everything out of the numerator, we just stick a 1 up there. If we had something else to put there, we would leave that there. But since we don't have anything else there, and now we do 1 over, use our calculator, 3, y to the x 3 equals 27 times p, which is just written 27p. Does that make sense, Faith? Let's see if I'm covering all your kinds of problems. So if you have a fraction like number 8, so let's put number 8 in our notes because it's a little bit different. So example 8. If you have a fraction being raised to a negative, we can take a shortcut. We can just flip that whole thing and raise it to a positive. Now, we are going to square negative 8/7, and that means it's going to be negative 8 squared over 7 squared. And if you'll do on your calculator 8, so yeah, I wonder if you use parentheses in here.
Yeah.
You don't have to use the parentheses. Some calculators you have to use the parentheses. We want to square negative 8. On your calculator, you do not have to put the grouping symbols there. So 8, the negative button. So for the top here, we're going to do 8, the negative button. And then there's actually an x squared button. So you have to do 8, negative button, x squared. You don't even have to hit equals. It'll tell you it's 64. So the numerator of our problem here is 64. And then 7 squared on your calculator. 7, x squared button is 49. So your final answer here would be 64/49. Any questions? Have you guys done these before? You have done these before? No, some yes, some no? Okay. Let's do number 13. Let's look at this example. Oh, actually, let's look at the back of your page first. I don't even know if we've done enough. So let's do this because I don't think we've done enough to get through the whole worksheet. Instead of 2 through 26 even, we're just going to do, we're going to do 1 through 18 all. 1 through 18 all. You guys here? We'll do those tomorrow. We're going to do some of those tomorrow. So we're going to switch it to 1 through 18 all, and I think we've done something that looks like all of those. Is everybody clear on that? We kind of ran out of time since I gave you time for your test. So 1 through 18 all, I'll adjust it on Canvas in case you forget.